So now, in this video, we're going to look at the JFET current sink again. So I used a 330 ohm resistor. I made this diagram a long time ago. Don't know what current I was shooting for. We'll see what we get in this video. So we got the source and the gate, a resistor between them. We can measure the current anywhere along the current path of the series components. So when we add the LED, we could measure it up there, in between there, down there. It doesn't matter. So in any case, the JFET has a property. There's a maximum current called the IDSS when the gate and the source are tied together that each J310 in this case can provide. Doesn't matter what the JFET is, there's a range of currents they might provide when you got that IDSS. Then you add a resistor between the source and the gate, and you will get a set amount of resistance that's lower than the maximum. That's the main thing to be aware of, even as supply voltage changes. So we will measure that. We will also grab an LED later on and add it to the circuit. So going to grab my multimeter, and we are going to set it to measure current. I don't have to move the red probe for anything than high current. It's going to be in the milliamp range right there. And now we got to be careful. So we got to complete the circuit through the meter. That is the main takeaway. So first, we're going to start with the black probe, and I can go to where the jumper is, right there, and then we will add the red probe right here, and I'm going to clip this jumper, and again, this needs to be part of the current path. So we got to go down to where the gate, the bottom pin there, the source is the middle pin, there's a resistor between the two, and we're going to plug it into the gate. So there you can see we got about 5.8 milliamps of current, it looks like, with no load. And that should stay the same even if we bump this up to 12 volts right there. You know, it might change just a speck, you know, but practically the same voltage, same amount of current right there, even as the voltage changes. So that's with no load. I'm going to put this up out of the way. You don't want to accidentally measure a voltage when you have the meter set to measure current. So I'm going to move the resistor down one spot and the transistor down one spot right there. So again, drain on top, the source in the middle, and gate at the bottom. And we are going to put an LED to the positive supply up there, long lead the anode, short lead the cathode, down one spot. And we have to complete circuit by putting, or give the current a path through the meter. So again, that's with 12 volts. We got the same amount of current. We set a current, even though now the red LED is dropping a couple volts, you might think that might change things. And we go down to 8 volts, and looks like current changed just a speck, but holding pretty steady. Let's see what happens with the blue LED. Again, blue LED drops another volt above what the red one does, drops 3 volts instead of 2. And again, it's still holding steady right there, just a little bit shy of 6 milliamps of current, and it should stay, you know, relatively stable as we change the supply voltage, just changing a spec right there. But in any case, it's another example of using the JFET, and again, you want to be careful, disconnect everything when you got it set to measure current, because you don't want to accidentally measure voltage. The meter doesn't limit current, and so if you try to measure a voltage source, if you don't have current limited, like I do with my power supply right there, then you could pass too much current through the meter and probably blow a fuse. You know, it might damage the meter as well, but most likely you'll blow a fuse in there and you'll have to replace it. But in any case, that's about it. It's just another example of the JFET. Again, the JFET is on the low side of the load, most likely, and therefore it is a current sink. So as far as the load's concerned, the JFET is bringing the connecting to ground right there. So it's sinking current as far as the load is concerned and setting that current. But you can call it a current source as well. Anything that sets a current, you can call a current source, whether it's sinking it or actually sourcing it. Sourcing is when it's on the high side. So yeah, that's about it. So thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.